Hello everyone. In this video, we're going to go over a homework problem from 8-2, namely 8-2-29 or 8.2.29-T. This is question 9 in the current semester's homework, but this of course references against the textbook. So here's the question. An online poll asked, do you believe in the Loch Ness Monster, or do you believe that it exists? Among the 21,540 responses, 63 were yes. And we're told to use a significance level, or alpha, of 0.05 to test the claim that most people believe in the Loch Ness Monster, believe that it exists. So again, the fact that here's our claim is not worded in exact numbers, but we can go ahead and say that if most of them, the proportion P is greater than 0.5. So this is the claim in terms of symbols. And then if we look at the options over here, we'll be able to select the correct null and alternative based off of that. So after we do our hypothesis test, we're asked, how does the conclusion affected by the fact that internet users who saw the question could decide whether or not to respond? So we're looking at a voluntary response sample, so we do need to consider that after a hypothesis test. So the null in this case is going to use equal, so that means it's got to either be A, B, or C. And this is a right-tailed test, so the correct answer is B. So in the second part of the question, we're asked to identify the test statistic for this hypothesis test. So it's a technology problem, so to do that, what we're going to go ahead and do is look at using StatCrunch as it's built right in. And then under stats, I'm going to go to proportion stats, one sample. And then here, we're not given the raw data. We're already told that I'd have to check again. Let me check. 63% said yes. So we want to be careful here. This is not the number, 63% is not the number of successes. We know that 63% of the 21,540. So let me go ahead and just calculate that. You could always just type it into Google. I believe Google will even parse it for you, or you could just multiply 0.63 times 21,540. I believe that's our number. So here it is. Of course, that's not perfect. So what we can do here is just round it naturally, because the problem or the homework checker, the one in the background that checks your answer if it's correct or not, does allow for a little bit of error, like plus or minus 100th of a point. So let's go ahead and just round that naturally to 13,570. So that was an old recording. So let's go back to this. So I need StatCrunch. There it is. So 13,570 is the number of successes out of the 21,540. So 21,540. This is a left-tailed test. So our alternative, our HA or H1. And you don't necessarily need to do this. You don't need to show the significance level in the output, because we're just going to do a quick comparison of the p-value against the significance level. All right, so the test statistic for proportion here is the z-stat. So if we take this, we want 2 decimal places, so we're going to need to round this up to 0.16. And the p-value rounding to 3 decimal places. So the p-value, 3 decimal places. This is really small. So the p-value is just going to be 0.0000 here. And if we just pause for a moment and think about why we have such a low p-value. So if we're looking at our statistic right here, this is definitely in support of this claim, because 63% is significantly more than half. So what we're going to want to do is reject the null, so we go to our alternative, because this sample, of course, is supporting our claim. So if we just compare the p-value with the significance level, so what we need to do is consider the p-value and its relationship to our alpha. So 0 is definitely less than 0.05. And if the null is low, if the p-value is low, the null must go. So let's move me over here, and the null must go. So reject the null, so either C or D. And as I just mentioned, this is good for our claim. So because our claim is in the alternative, so we reject the null, we go down to our alternative. So there is sufficient evidence to support our claim. So let's check that. Check the answer. Very good. And the last one is, how is the conclusion affected by the fact that internet users who saw the question could decide whether or not to respond? So again, voluntary response samples really skew the data. And, well, and I should say skew loosely because skew has a certain meaning in statistics. So what I really should say is, I don't want to overload that word. So I should say that a voluntary response sample could invalidate the conclusion. So let's see what one that's talking about. And since any of the site's users are allowed to respond, the conclusion is invalid. That one could be it. Let's look at our other options. The sample size is sufficiently large. That necessarily does not help here because, again, maybe that site just gets a lot of traffic. So here, this is what we're looking at, because it is saying, okay, this is a voluntary response sample. So this kind of alludes to it, but C is more in line of the terminology associated with statistics, and a conclusion may not be valid. And just to check part D, this is not true because technically anyone was allowed to respond. It's just we have, again, a voluntary response sample. So we check that. And that completes the question. Hope that helps.